Hi there, my name is Rankeya Datta, and I'm currently a postdoc at the University of Illinois at Chicago. I got my PhD from the University of Michigan under Karen Smith. I work in commutative algebra and algebraic geometry, and I enjoy thinking about singularities defined via the Frobenius map, local cohomology, finite generation questions, uniformity results in commutative algebra, valuation theory and local uniformization, and questions stemming from the Dirac-Saman theorem. My recent work revolves around the following motivating question. For an R algebra S, when is the R dual of S non-trivial? This very simple sounding question has applications in numerous areas of research, like the theory of Frobenius splittings, the notion of an excellent ring and prime characteristic, tight closure and uniformity results like uniform Martin-Rees, ramification defect, which is turning out to be one of the main obstructions to local uniformization in positive characteristic, and the Dirac-Saman theorem and the theory of splinters. Let me describe some work related to this question in characteristic P that I did. So we're going to fix a domain R of characteristic P. And so then what does the non-triviality of the dual of the pth roots of R tell us about R itself? So the next theorem tells us that there is a deep connection between this question and Grothendieck's notion of an excellent ring. So suppose R is a Noetherian with fraction field K. With Karen Smith, I showed that if the Frobenius on K is finite, then R is in fact excellent if and only if the R dual of R1 over P is non-trivial. Later on, Takumi Murayama, we showed that if R has a finite normalization, so for example, if R is normal and the R dual of R1 over P is non-trivial, then R is in fact excellent in codimension 1. One of the long-standing questions in this area was that if R is excellent, then is the dual of R1 over P non-trivial? And moreover, are excellent F-pure rings Frobenius split? Takumi Murayama and I showed that unfortunately, this is not the case. We obtained negative answers to both questions. In fact, we showed that there are excellent Henselian discrete valuation rings R arising in rigid analytic geometry for which the dual of R1 over P is in fact trivial. I also want to describe some work I did related to the triviality of R1 over P, the dual of R1 over P and valuation rings. So we are going to say a domain R of characteristic P is F split if R is a direct summand of R1 over P. So Karen Smith and I studied Frobenius splittings in the highly non-Noetherian setting of valuation rings, and we found many connections between Frobenius splittings and the notion of ramification defect, which is one of the main obstructions to local uniformization in positive characteristic. So for example, in the function field setting, so suppose K is a function field of a variety over a perfect field small k, and you have a valuation nu of K over K, whose valuation ring is R nu. And I'm going to denote the restriction of nu to the subfield of P powers as nu P. So then we showed, for example, that nu over nu P has no defect precisely when nu is what is called a quasi-monomial valuation, which is a higher rational rank analog of a divisorial valuation. And using this result, Smith and I were able to obtain a very surprising characterization of F finiteness of valuation rings of function fields. We showed that F finiteness is equivalent to the valuation ring being Noetherian. And then I was later able to use this defect notion to show that when nu over nu P has no defect, then in fact the valuation ring is Frobenius split. And when nu over nu P has maximal defect, then the valuation ring is not Frobenius split. But somehow the relationship between defect and Frobenius splitting is not very well understood when the defect is not one of two possible extremes, which is something that I'm thinking about at the present moment. And finally, I want to talk about some work I did with relation to the motivating question and the notion of a splinter. We're going to say that a Noetherian domain R is a splinter if R is a direct summand of any finite extension S. The famous Dirac-Saman theorem is the assertion that regular rings are splinters. And now that we know that this is a theorem, splinters represent a characteristic independent notion of singularity. So natural open question is, if phi from R to S is a flat map of Noetherian rings with geometrically regular fibers, then does the splinter condition ascend from R to S? And the reason why this is a natural question is that for most other notions of singularities, like reduced, normal, Cohen-Macaulay complete intersection, Gorenstein, etc., the notion of singularity does ascend under flat maps with geometrically regular fibers. Moreover, I want to emphasize that the direct summand theorem is in fact a very special case of the above open question. So in joint work with Kevin Tucker, we obtained an affirmative answer to this question when the map phi is essentially étal. We also showed that when R is a local excellent ring, then the completion of a splinter is also a splinter. But in general, this open question is wide open. And in next week's talk, I'm going to discuss some further research I did related to the splinter condition and valuation theory. Thank you.